to continue with our log operations, and had a bit of a mishap with the second half of the video, so I'm re-recording this one. One other problem I wanted to do before we change over to a different type is one like you see in front of you here. The difference with this one is you'll notice that there are numbers in front of several logs. And that for some reason that tends to bug people, particularly if there's a coefficient in front of more than one log. What you're going to deal with it, of course, is just like we did on that problem back a couple. You have to get the numbers in front out of the way. You cannot use the properties about adding logs and subtracting logs until you've dealt with the numbers in front. So we're going to use the plug rule in reverse, and we're going to pull those numbers back front. Now the important one is this second one, the 1/4. When you pull it back and put it on the 16, do not move the negative sign. Leave the subtraction there. It'll make a nightmare for you if you move the negative sign. So what I actually have here then is the natural log of 6 squared minus the natural log of 16 to the 1/4 power equals the natural log of 4 minus 2x. Okay, 6 squared is no big deal. We got 36. Now, the question is, how do I do 16 to the 1/4 power? Which you'll, of course, remember means we have 16 to the first in a 4th root. And so you're asking yourself, how many times do I have, or what number can I take to the 4th power to get 16? And so that would be 2. And we'll leave the right-hand side sitting there. Now that you've gotten rid of those numbers, then you worry about the fact that you have a log minus a log. You'll notice here it does not matter that these are natural logs. The rules apply with whatever base log you're using. So we know then that using the second property, that when you have a log minus a log, that's the same thing as division. So this would be 36 over 2. In which case I have the natural log of 18 equals the natural log of 4 minus 2x. Once I have that, since I have my logs equal, I can set my arguments equal. Now it's just a simple solve for x. I'm going to add the 2x over, subtract the 18, which will give me negative 14, and will leave me with x equals negative 7. Now, does that instantly mean, oh no, it's a negative answer, I need to throw it out? Well, if you look back at the original problem, and you would look at it before you moved any of the numbers, you'll actually see there's only one place where we have an x in it, and that was in that far right-hand term. So we're really asking ourselves, if I do just that natural log of 4 minus 2x, and I put negative 7 in it, will that actually be a bad thing? Well, the two negatives are going to make a plus, so I'm going to end up with a positive number. So in this case, this is a prime example of where a negative answer works. We still get the log of a positive number, and it's all okay. The other problems I want to talk to you about are solving what we call exponential problems. And that's when you have your variable is the exponent, and we need to solve for x. Now, a couple days ago, you solved some kind of like this. You might have, for example, solved something like we did 5 to the x equals 25 to the x plus 1. Well, if that's the case, then we know when we had those, we made common bases, and we said, well, we'll make them both base 5. And we changed 25 into 5 squared, so they would have common bases. We could then solve them. But in this case, is there a common base to 8 and 117? I don't think so. So in this case, we can't make common bases, so we need an alternative method. And this is actually where logarithms become hugely powerful. Logarithms are used in math to solve for exponents. That's a critical concept. That's why mathematicians need logarithms. And so that's a biggie. I'm sure it's on your journal. And of course, that merits some cherries with it. So, key factor here. If I want to solve for x up there, I can't make them have common bases, but I have to find some way to get the x down front. So instead what I'm going to do is I'm going to choose to use the plug rule. But if you remember, the plug rule back here says you have to have a log on it, and then you can pull the power down in front of the logarithm. Well, in our case, we don't have a log in front. So instead what we're going to do is we can choose to put logs on it. As long as we do the same thing to both sides of the equal sign, it's perfectly legal. You can use a common log or a natural log, doesn't matter. I'm going to use a common log here. And I'm going to put a log on both sides. Once I have those logarithms there, then I am allowed to take the exponent, which in this case is just x, and move it down front. In which case that will give me x times the log of 8 equals the log of 117. That's what we call logging and plugging, if you've talked to some of my previous students. We added logs to both sides, and then we plugged or moved the x down front. Now realize this is x times the log of 8, so if I want to get x by itself, I simply need to divide by the log of 8. And if I do that, then these are not going to come out to nice answers, and you are going to go to your calculator and simply plug this in. What's the log of 117 divided by the log of 8? And as you can see here, I already have it up from the previous class. If you just put in a fraction and then do control your 10 to the x key so you get a log on there, you can type the 10 in or you don't have to, because as soon as you hit enter, it's going to assume you mean base 10 and put them in for you. So now I'm going to put in another log. I don't need to bother with the base 10 because it'll fill in it for us. Put my log of 8. It adds the base 10s later. And we see that our answer is approximately 2.29. You're going to round your answers off to 2 decimal places. So we would say in this case, x is approximately 2.29 would be the power that makes that come out equal. This second problem I have up here is very similar, but it does have some extra terms in it, so I wanted to talk about that. But once again, if it's exponential and you need to solve for x, your number one strategy is to log and plug. So I'm putting logs on both sides so that I can bring the exponent down front. In this case, the exponent has multiple terms, so I'm going to put the 2x plus 3 down front times the log of 13. Now, why did I write that in parentheses? That's really, really, really critical. You need to realize that entire quantity times the log of 13. So when we go to solve for x, I don't think you want to distribute that log of 13. That's an ugly thing. Instead, you want to divide that log of 13 to the other side. That way you're left with 2x plus 3 equals this somewhat ugly fraction. Realize those numbers are inside the log. I don't often write the parentheses, but when you hit your put it in your calculator, it will add the parentheses. Okay, now, last but not least, how do you get x by itself? Well, we need to subtract 3 and divide by 2. Okay. If you put this all in your calculator continuously so that you don't round off any numbers, you could plug in that fraction, then you're going to subtract the 3, and at the end, if you hit enter on those, then you can divide by 2, and you'll be down to your final answer. Once again, these will be ugly decimals. You're going to be rounding them off. In this case, we're going to go actually to 2 significant digits because this one comes out 0.0042, very small answer. Now, do you have to check these answers for positive or negative? No, because your original problem did not start out with any logs in it. There's no logs up there, so you don't need to check your answers. Okay. Last thing we're going to do here today is we're going to look at solving some equations with e and natural log in them. And you actually love to see these kind of problems because they are really easy and really short. If you want to plug these in here, we know to get rid of an e, what made e cancel out? Well, of course, it was a natural log. So if I natural log both sides, this is pretty cool. Once I put the natural log on both sides, I have the natural log of e to the 9x and natural log of 11. Well, we know natural log and e eliminate each other, so consequently we're left with 9x equals the natural log of 11. Then all you have to do is divide by 9 and punch that in your calculator. And once again, you will have 0.27. Okay, the next one is somewhat similar. I did want you to notice, what do you do though when there's a 6 times that e? What do I do with that 6 in front? You cannot use a natural log to get rid of the e unless the e is all by itself and isolated. So you have to isolate e first. Then you can add natural logs to get rid of the e. So in this case, I'm going to divide the 6 over, which is going to give me e to the x plus 4 equals 14. Then, now that it's isolated, I can add logs to both sides. So I'll have natural log of e to the x plus 4 and natural log of 14. The natural log and the e cancel each other out. And I have x plus 4 equals natural log of 14. Last but not least then, I need to subtract 4. And once you'll punch it in your calculator. All of these type of problems will result in using your calculator at the end of the problem. And you'll discover this one ends up being actually approximately negative 1.36. Okay. Last but not least, I need to show you what you do when you have a problem with just a natural log in it. Well, there's also shortcuts you can take with natural log problems rather than having to go through the links we went with the others. Normally on this one I would have said, oh, I have a log on only one side, I should change the exponential form. But with natural logs, there's a shortcut. Now still, you have to isolate that natural log. So this 6 that's sitting here in front has to go. It's got to be gone. You have to have the log by itself. Then you can say, okay, if I have a natural log of x plus 2 equals 5, then I need to get rid of that natural log. And this is going to look strange to you, but it's legal as long as you do it to both sides. I know an e will take out that natural log. Well, the only way I can put an e with a natural log, I can't put the e inside the natural log. But what I can do is I can put an e on here, and then I can raise the natural log as the power on the e. But of course, if I do that to the left side, I have to do that to the right side. So now I will have e to the 5th. E and natural log cancel out, and I will have x plus 2 equals e to the 5th. And consequently then, I've gotten rid of my e and my natural log. And it's an easy finish from there. Subtract 2, we would have e to the 5th minus 2. And at last, yes, you'll put that in your calculator and work it down to a decimal, and you will get approximately 146.41. So there's the trick to working with natural logs. You can get rid of them using an e. So actually, you love to see e's and natural logs in your problem because they take each other out. They actually make it a shortcut. With that, you should practice on that worksheet. That worksheet is really, really crucial. That is the key to all log solving. I can't say enough how important it is to do today's homework. So, now, be good for the rest of the block and accomplish something. If you have any trouble, I'll be back later today. Catch me during seminar or catch me tomorrow.